The 21st century ushered in a new age of energy production marked by significant technological advancements and innovative methods. Among these innovations, fracking, short for hydraulic fracturing, emerged as a game changer in the energy sector. This groundbreaking technology unlocked vast reserves of natural gas and oil trapped deep within shale rock formations, which were previously considered inaccessible. By making these resources viable, fracking revolutionized the way we think about energy extraction and availability. The promise of fracking extended beyond just energy extraction. It held the potential for energy independence and significant economic growth. However, this promise was not without its controversies. The advent of fracking sparked intense debate across various sectors of society. Concerns about its environmental impact quickly surfaced, raising questions about the sustainability and safety of this method. Fracking involves injecting a high-pressure mixture of water, sand, and chemicals into the ground to create fissures in the rock. These fissures allow the trapped hydrocarbons to be released, making it possible to extract valuable natural resources. Natural gas, primarily methane, is the most common resource extracted through fracking, providing a cleaner alternative to coal. However, fracking also produces oil and natural gas liquids, adding to the diversity of energy resources available. This newfound abundance of energy resources positioned the United States as a leading energy producer on the global stage, reshaping the global energy landscape. The rise of fracking had profound economic and geopolitical implications, influencing global energy markets and international relations. Domestically, it reduced reliance on foreign energy sources and stimulated job growth in many regions, revitalizing local economies. However, the environmental consequences of fracking remained a subject of intense scrutiny and concern. Balancing the economic benefits of fracking with its potential environmental risks became a complex challenge for policymakers and industry leaders. Policymakers, scientists, and the public grappled with the trade-offs associated with this controversial technology, seeking a path that maximizes benefits while minimizing harm. Community meetings and public forums became common as people from all walks of life voiced their opinions and concerns about fracking. As the debate continues, the future of fracking remains uncertain, with some advocating for a shift towards renewable energy sources to ensure a sustainable future. The story of fracking is still being written, and its ultimate impact on our world will depend on the choices we make today. Fracking is a complex technological process that demands precision and expertise. It involves multiple stages, each requiring specialized equipment and skilled personnel to ensure the operation is conducted safely and efficiently. It begins with drilling a well deep into the earth, often extending thousands of feet below the surface. This initial phase is crucial as it sets the foundation for the entire fracking operation. The drilling must be precise to reach the targeted shale formations. The wellbore is then encased in steel and cement to prevent any leakage into surrounding rock formations. This casing is essential for maintaining the structural integrity of the well and preventing contamination of nearby groundwater sources. This protective casing ensures the integrity of the well and safeguards groundwater resources. Groundwater protection is a top priority, and the casing acts as a barrier to keep the fracking fluids and hydrocarbons contained within the well. Once the well reaches the shale formation, a specialized perforating gun creates small holes in the casing and surrounding rock. These perforations are strategically placed to maximize the efficiency of the fracking process. These perforations act as channels for the fracking fluid to enter the shale. The placement and size of these holes are carefully calculated to optimize the flow of the fracking fluid into the rock. Next, a mixture of water, sand, and chemicals is pumped into the well at extremely high pressure. This fluid mixture is designed to create fractures in the shale rock, allowing the trapped oil and gas to be released. This pressurized fluid creates fractures in the shale rock, effectively unlocking the trapped oil and gas. The high pressure is necessary to break the rock and create pathways for the hydrocarbons to flow. The sand acts as a proppant, keeping the fractures open and allowing the hydrocarbons to flow back up the wellbore. Without the proppant, the fractures would close and the flow of oil and gas would be restricted. The extracted oil and gas are then collected, processed, and transported to refineries and distribution centers. This stage involves a series of steps to ensure the hydrocarbons are safely and efficiently moved from the well to the market. The fracking fluid, now mixed with formation water and hydrocarbons, is also recovered from the well. This recovery process is essential to minimize environmental impact and to reuse the fluid in future fracking operations. This wastewater requires careful treatment and disposal to mitigate environmental risks. Specialized facilities are used to treat the wastewater, ensuring that harmful chemicals and contaminants are removed before the water is either reused or safely disposed of. The advent of fracking ignited a firestorm of political controversy. Its rapid rise in the energy sector coincided with growing concerns about climate change and environmental protection. Proponents of fracking touted its economic benefits, emphasizing job creation, energy independence, and reduced reliance on coal. They argued that natural gas, a cleaner-burning fuel than coal, offered a bridge to a renewable energy future. Opponents, however, raised alarm bells about the potential environmental consequences of fracking. They pointed to the risks of water contamination, air pollution, and induced earthquakes. The use of hazardous chemicals in fracking fluid and the disposal of wastewater emerged as major points of contention. Public opinion remained sharply divided, with vocal advocates and critics on both sides of the issue. The debate over fracking transcended partisan lines, pitting environmental concerns against economic interests. Policymakers faced the daunting task of balancing the potential benefits of fracking with the need to protect public health and the environment. Regulations governing fracking varied widely across states and countries, reflecting the complex interplay of science, economics, and public opinion. Section 4. The environmental price tag, water and seismic concerns. The environmental impact of fracking emerged as a focal point of the debate, drawing attention from scientists, policymakers, and the general public alike. Water contamination in particular became a major concern. Communities near fracking sites reported changes in water quality, with some experiencing foul-smelling and discolored water. Fracking requires vast amounts of water, which can strain local water supplies, especially in arid regions. This demand for water can lead to conflicts with agricultural needs and residential water use. The potential for leaks and spills during the transport, storage, and injection of fracking fluid raise concerns about groundwater contamination. Even small spills can have significant impacts on local ecosystems and water sources. The chemical composition of fracking fluid also fueled anxieties. These fluids often contain a mix of water, sand, and various chemicals, some of which are known to be hazardous. While the industry maintained that the chemicals used in fracking fluid are present in minute quantities and pose minimal risk, the lack of transparency about the exact chemical makeup has led to public distrust. Critics argued that these chemicals could contaminate aquifers and drinking water sources, posing long-term health risks to nearby communities. The long-term effects of these chemicals on human health and the environment remained largely unknown. Research is ongoing, but definitive conclusions are still years away. Another environmental concern associated with fracking was the potential to trigger earthquakes. This phenomenon, known as induced seismicity, has been observed in several regions with active fracking operations. The injection of high-pressure fluids into underground rock formations can alter stress levels, potentially inducing seismic activity. This process can create fractures in the rock, which may lead to small tremors. While most induced earthquakes are small and barely perceptible, they can still cause concern among local residents. The fear of larger, more damaging quakes looms over communities near fracking sites. Some induced earthquakes have been large enough to cause damage to property and infrastructure, leading to costly repairs and heightened anxiety among affected populations. The link between fracking and induced seismicity added another layer of complexity to the debate. As more data becomes available, the conversation continues to evolve, with stakeholders weighing the economic benefits of fracking against its environmental risks. Section 5. Economic boon, jobs, growth, and energy security. The rise of fracking had a profound and transformative impact on the US economy. The shale gas boom created thousands of jobs in the energy sector and related industries, boosting employment. From drilling and well construction to transportation and logistics, fracking operations spurred economic activity across the entire supply chain. Rural communities, often struggling with unemployment and limited economic opportunities, experienced a significant resurgence. Fracking also contributed significantly to US energy independence. The abundance of natural gas unlocked by fracking reduced reliance on foreign energy sources, enhancing national security. This newfound energy security had geopolitical implications, enhancing US leverage in international affairs and negotiations. Lower natural gas prices also benefited consumers, reducing energy costs for households and businesses alike. The economic benefits of fracking extended beyond the energy sector, reaching various industries. The availability of cheap natural gas made US manufacturing more competitive globally, boosting exports. It also provided an alternative to coal for electricity generation, reducing greenhouse gas emissions significantly. However, the long-term economic viability of fracking remained uncertain, subject to fluctuations in energy prices and the availability of government subsidies.